All right, we got what's called exponential functions. Okay, so I'm going to show this right here, and I'm going to zoom in on it. Okay, why is it not coming up? Okay, is that working? There we go. All right, so come out a little bit. All right, exponential functions are really simple. Remember how we started talking about quadratics, cubics, constants, linears, right?
Yeah.
And what happened to all those? The exponents changed, right?
Yes.
So a linear had an exponent of 1, right? Yeah, constant had an exponent of 0, right? A cubic has an exponent of 3. Good. Quadratic with 3, right? I went out of order there on purpose, just kind of trick your brain a little bit. So quadratic was 3. Quadratic is 2. Cubic is 3, right? What was 4?
Quartic.
Quartic. 5?
Quintic.
Quintic. Okay? So, a lot of stuff, right? And we're going to get there. Everybody's catching.
What lesson?
Huh?
What lesson?
This is lesson 4.1. Okay? Now, with exponential functions, listen to this. Exponential functions. Exponential means that the variable is an exponent. Okay? The variable, the letter, is an exponent. Okay? So it's not that bad. And the way it's written is like this purple one. F of x is equal to b to the x. B is a constant. Okay? And x is the variable. Okay? And we're showing that it's a variable by saying the function with respect to x, right? And then whatever we had in respect to, that's the exponent. So 3 to the x, that's an exponential function. 5 to the x, an exponential function. Does that make sense?
What is the b again?
B is a constant. It's like any number, but it's always the same number. It doesn't change. Okay? All right. So that's the confusing part. Okay? Then we got something that takes it a little bit out of the confusing part. All right? So we have something that's called an exponential function that's a decay or growth. Okay? Exponential functions grow exponentially. Okay? Does anyone know what that means? It's like saying someone really large is really large. You're like, okay, I don't understand what you're saying. You just use the same adjective as a verb. Okay? So I guess when we think of exponential functions, we think of them as, when something grows exponentially, it means like, think of something that's squared. If something's squared, right? 5 squared is 25, right? But what's 5 cubed? 125, right? Okay? So think of like 2's. 2 squared is 4. 2 cubed is 8. 2 to the 4th is 16. 2 to the 5th is 32. 2 to the 6th is 64. 2 to the 7th is 128. 2 to the 8th is 256. 2 to the 9th is 512. 2 to the 10th is 120 or 1024. Right? So it's getting bigger fast, right? Okay? That's exponential growth. It gets big fast. Ooh, can you get that? Okay? So exponential growth grows fast. Okay? Exponential decay goes down fast. Okay? Now, growth kind of looks like this. It doesn't always, because it starts at different places. So it could start way up here and go up, right? But it get a general idea of exponential growth is going to look, instead of putting it on a graph, let's just go, it kind of looks like this, where it goes up. And it goes up quickly. Okay? And then decay goes down. It goes down quickly. So let's not look at it as on a graph, but let's look at it as it just goes down quickly. Okay? But with decay, and this is very important, with decay, it never reaches that spot. Now let's talk about, let's say it's decaying down to nothing, right? All right, so it's kind of like this. If I walk halfway to that door, how close am I going to be to the door? Halfway. Okay, now I walk halfway to the door again. How close am I? Halfway. Okay, halfway to the door, how close am I? Halfway. Halfway to the door, how close am I?
Halfway.
Halfway to the door, how close am I? Halfway, halfway, halfway. Right? Do I ever reach the door?
No.
No. Technically I do, because my feet are too big to go halfway after a while, right? But mathematically speaking, philosophically speaking, I'll never reach the door. I'll never get to go through the door. Okay? That's what this is saying in decay. You'll never reach that bottom part, whether it's 0 or 1 or 18 or 158. You'll never get to that bottom level because there's an area where you can't get to. Does that make sense? You'll never get to 0. Okay? In other words. Now, that just means that this inside piece will never get to 0. It doesn't mean that this times this, because you know what I'm saying, whatever this is, it's going to make it smaller and smaller and smaller. Does that make sense? But it will never reach 0. Okay? So there's a bottom. There's a bottom to it, right? Whereas with exponential growth, there's no top. It goes up. But there is a bottom to it, right? It started somewhere, and then from there it goes up. Does that make sense? And it goes up quickly, right? Okay, so that's the difference between growth and decay. Okay, they're inverses of each other. Not totally true, but they're kind of, not quite. But we'll talk about that. They're not inverses, but they're like each other upside down. Okay? All right, now, what are they inverses? No, okay. Okay, well, kind of. Yeah, I guess they are. All right, anyways, I digress. Now, let's look at some functions and see in your homework, all right, what is growth and what is decay. All right, so this is homework 4.1, and you're starting with 12, right, and we're going to go to 17, okay? So 12, number 12, it says, hey, is this exponential function? So, look at 12 and tell me, is 2 to the x to the 10th, 2 times x to the 10th, is that an exponential function? And then if it is, why? And if it isn't, why not? So what do you think? No, why not? There's a number on the exponent. Finally, I got a class who's listening. All right? First period, it took them like 10 minutes to figure that out. I had to explain twice. I have it on film. So, I love it. You listen. Yeah, if there's not an exponent, right? If there's not a variable in the exponent, if x isn't in the exponent, it's not exponential, right? In other words, if this weren't a 10, if it were a 5, we would call it a monomial quintic, right? A quintic monomial, right? So this has a name for it, I don't know, 10th degree, right? Monomial, okay? But it's not exponential. All right, number 2, which is 13. What about this one? Is this exponential growth? He says no, he says yes. So why? Why not?
I say no because it's 0.
You say no because it's 0 perfect, and you say yes because?
I was guessing.
Guessing. Why would you say yes though? Because you were thinking something about the exponent, right? Yeah, and the exponent is an x. So guess what? You're both kind of right. Okay? But you're really right. You're kind of right, but yet you're wrong at the same time. And this is what you're thinking, because I think you learned it from me last year with exponential growth. See, this is not growth or decay, right? But it is exponential function. Technically, it's an exponential function because there's an exponent as the exponent, right? There's a variable as an exponent. Okay? But, does it grow? What is 0 to the second power? 0. What is 0 to the 8th power? What is 0 to the 20th power?
0.
And it doesn't grow and it doesn't decay, right? So it's neither growth or decay, but it is an exponential function that looks like a constant, right? Because it's always 0. Does that make sense? What other number would do that? There's two numbers that do that. 0 and 1. Very good. Because 1 raised to the 18th power is still 1. Right? Alright. Bear with me, guys. I know I'm going to go really fast, but we got 6 minutes. We can do this. Okay? Alright, so this is exponential function, not growth, not decay. Okay? Alright. Then, what is this? Is it exponential function or not? Why and why not? Anybody? Come on, somebody.
Which one?
Yes.
Yes, why? Why would this be exponential function? Where is the exponent? What is the exponent? Is it a variable?
Yes.
Yes, then it's an exponential function. Right? Now, is it growth or decay? That's the tricky part. Now, it says 1 times the quantity. So, in essence, this should look like that. So, it's 0.5. Alright? Now, if this number in here is bigger than 1, it's going to be growth. If it's less than 1, meaning between 1 and 0, it's going to be decay, right? So it's decay. If this were 1.05, what would it be? Growth. So yes, this is decay, and this would be growth. Does that make sense? Cool. All right. I'm going to pause it there, and then I'm going to take it to the next level.